Unit 2, Permutations and Combinations. Quickly here, we're going to go over where they are used and how to work the problems in this unit. So where's this used? 2010, Alberta got a new digit on its license plates. Its province's license plates. We used to have 3 letters and 3 numbers. Then we added a new one in 2010. Reason being, we were running out of license plates. You can predict this and figure out how much time an extra digit will buy you using permutations and combinations. Same thing goes for password security. Figuring out which is more secure, an 8-digit passcode or a 16-digit passcode, even if you can't use uppercase and lowercase. You can figure out what's more secure using permutations and combinations. Biggest key for this unit, it's important for every unit, but even more so for this one, is an active read. If you have a hard copy in front of you, highlight, underline things. Or if you don't, if you're working off of an electronic copy, rewrite key info on a piece of paper. Make sure you have the problem cornered and know what they're asking you. Example from lesson 1. New renovations completed at Prestwick High School. There will be 7 entrances. I know that's going to be important. It's one of my numbers. In how many different ways can a student coming from math tutorial enter and exit any entrance? And then for B, we've got different entrance. That's the key difference in part B. And then part C, it has to be the same entrance. So figuring out what the keys are. When you are working a new question, sometimes you're not going to be sure how to go about solving it. A diagram can be a good first step in figuring out what you have to do. So in this case, I'm just going to draw a very simple looking building, and I'm going to put 7 doors. Now, having gone through lesson 1, another good idea in this unit is we're dealing with the fundamental counting principle. So I know I'm going to enter and exit. That's likely 2 choice points I'm making there. Start off with this. How many ways can I enter the building? And how many ways can I exit the building? Getting these kinds of diagrams and templates written down frees up your mind. You don't have to hold this stuff inside of your head. It's there for you to see. It gives you a bit more space in your brain to work out the scenario in your mind, doing a bit of visualization. Picturing yourself entering this building. Better yet, relate the question to your own experience. I think of, there's a small town schoolhouse where I used to live. That's what this building kind of looks like. If I picture 7 doors around it, it helps me sort out this problem in my own head. There are how many ways to get in? 7. Then I can enter and exit through any entrance. If I pick this entrance, then I can go back out through any entrance, so I'd still be able to use that one. And I'd have 7 choices for part A. So a question like this can seem like a completely new thing. You don't know what you have to do or what you're being asked. Underline key info, diagram it out, get your fundamental counting principle here sorted out, work out the scenario in your mind, relate it to your own experience. It just gives yourself a bit of time, gives your brain a bit of time to wrap itself around the problem, and then you can start working things out. Something else that I recommend people keep in mind as they're working through the whole unit, progressing through the different lessons, is a list of key questions to ask yourself. So this can kind of narrow things down a little bit for you. First question, often overlooked, is what is the sample space? Another Another way of looking at that is, what choices am I actually making when I'm doing an arrangement here? What options do I have? So if we take a look back at the previous question, well, the choices I'm making are how I enter and exit the building. I'm making two choices here. And how many options do I have? Well, I have 1, 2, 3, 4, 5, 6, 7 different entrances and exits. Those are the choices available to me. So that's what I mean by sample space. Once you have that done, that brings us to the next question. Is there replacement? Or another way we can ask that question, can I use the same thing more than once? This previous question is an excellent example of this by comparing A and B. For A, I could enter through any entrance and then exit through any entrance. I could use the same one. I could enter through the same one I left with. This door doesn't become out of bounds once I enter the school. I could exit out of the same one. I can use that door more than once. So therefore I have 7 choices on the way in and 7 choices on the way out. 7 times 7. I didn't really answer that. Gives us 49. For B, I have to use a different entrance. So for B, I have 7 options to get in, but then I cannot use the same door anymore. So I lose an option on the way out. 7 times 6, 42. One word in here, any, different, totally changes things. And we can identify that stuff a bit more easily in these questions, in these problems we encounter, by going through this list of questions to ask yourself. Can I use the same thing more than once? In question A, yes. In question B, no. Talk a bit more about this one as you get to lesson 2 and lesson 5. Does order matter? Can definitely change the way that you approach a question. Are there restrictions? Sometimes there's things that limit what choices you can actually make in a given problem. Talk a lot about this in lesson 3, but there is a preview in this question we were talking about. In C, I must enter and exit through the same entrance. That is a restriction. So once I enter, I can only leave through the same entrance. So that puts a much tighter restriction on the options I have. I can pick any door going in, but then I have to use that same one and only that one going out. Limits what I can do. It's important to think about this restriction here because it changes the answer of the problem. Sometimes, or most of the time really, it's important to work out your restriction in the first place and then fill in everything else later. You'll also encounter in lesson 4 the idea of repeated or identical elements. So rearranging those doesn't change anything. You'll learn more about that in lesson 4. And finally, multi-case problems are where you might have 2 different scenarios that you have to do some fundamental counting principle with, and then you have to add them up afterwards. Not all of these questions are going to apply to every single problem you encounter in this unit, but if you're not sure how to work a problem, going through this list can really help you. Again, early on in the course, you aren't dealing with all of these at once, but as you get to the end, come revisit this list. Even with all of that, the active read, questions to ask yourself, there's no substitute for practice in this unit, all of these lessons. Especially this unit, a question's like a riddle. The first time you hear it, it's almost impossible to find the answer. That's why it's a riddle. But once you hear the answer even just once you know the trick, it's much easier to answer a simpler question. Question number 4 here from lesson 1 is another good example. So, here's the score at the end of the second period. Now we're looking for what possibilities are there, how many possibilities are there for the score at the end of the first period. So all we know is at the end of the second period, Flames have scored 6 goals. It is very common to go to this solution here. Well, that must mean 6 options for the Flames. Oilers have scored 3 goals at that point. 3 options for the Oilers. 6 times 3 in our fundamental counting principle will get us 18. But that isn't correct in this particular problem. This is where thinking about our sample space, let's see, so for the Flames, they could have scored 6 goals, 5 goals, 4 goals, 3 goals, 2 goals, 1 goal by the end of the first period. Or wait, if I'm thinking of a scoreboard, doing that whole idea of putting myself into that scenario, relating this to my experience of gone to a hockey game or any sport really, look at the scoreboard. What are the options? There's a hidden one here. They might not have scored at all at the end of the first period. There are actually 7 possibilities for what the score could be at the end of the first period for the Flames, and there are 4 possibilities for the Oilers, not 3. So the actual answer here is 7 times 4 equals 28. There's a little bit of a trap with that 0 there. Careful read, careful identification of the sample space, relating it to a scenario of looking at a scoreboard can help. You might not forget that 0 that way. But even more importantly, you go through this question once, it might catch you. But if we see a similar question later on, we'll remember that 0. So practice, practice, practice. And of course, if you're running into issues, you know where to find me.